Hello and welcome to another walkthrough. Now this time it will be Edexcel A-Level Paper 3-1 Statistics and Paper 3-2 Mechanics, June 2025, which I have never seen before. So this is going to be a blind solve for the entire paper under the real exam conditions. So along the walkthrough, I might be making mistakes, which I'll correct if I realize in the walkthrough. But if I don't, I'll annotate the video and I'll try to explain the worked solution and the thought process as simply as possible. At the end of the walkthrough, I'll mark the paper anyway. For those of you who make mistakes a lot of times, you might benefit from seeing me making a mistake and correct it later. So this walkthrough is not meant to just show you the destination of the solutions, but also show you the journey to the destination. If you feel like jumping to a particular question, you can use chapters in the description. Otherwise, stick around. You might be getting some tips along the way. If you are ready, I'll see you in there. Hi guys, just a quick one here. This statistics always blows my mind. So as you can see, for the past 28 days as of today, out of all the 7.7 thousand watch hours, more than 90% of those watch hours come from those of you who aren't subscribed to my channel. And that gives me an urge to beg you, please help support me by subscribing the channel. I will return this huge favor by creating more and more videos. I'm going to utilize my teaching experience for 10 plus years to create the videos covering tips and tricks and the hard bits in the topics that most students struggle to understand. It can either be a short video, a long video, but they will sure come up. So that is why you need to subscribe to stay tuned. I hope we have a deal. Let's get back to the walkthrough. And I'm going to start the timer now. Okay, let's go. Let's start with the statistic paper first. Yeah. Hang on, I'm just gonna, okay, here we go. Number 1, bag A contains 5 red, 4 yellow, and 3 green beads. Bag B contains red and yellow beads. Alright, okay. A bead is selected at random from A and a second bead from B. Given that the probability that both beads are selected are yellow is 3/16. Okay. I find the probability of selecting a yellow bead from bag B. Okay, so it's just an independent probability from bag B alone. Yeah, this is not a compound yet. So from bag B, a yellow bead, because bag B only contains red and yellow, right? So if we say that for bag B, right, the probability of selecting let's say a yellow bead is P. Yeah, because we want to find this probability. This is yellow bead, yeah? And then the rest will go to the red bead, which is 1 minus P, because there are only 2 colors in bag B. So that means if we go from bag A to bag B, yeah? So bag A, you can choose what? Okay, we want probability from bag B. Okay, maybe I was wrong about compound there. I think we need to compound it from bag A already here. So bag A we have red, yellow, and green, right? I think there is already a tree diagram there, so you can see. So that means, okay. So we want both beads being yellow, so that means we have yellow and yellow. So yellow from bag A is 4 out of, because there are 4 yellow beads and overall there are 12 beads, so 4/12 times probability of yellow bead from bag B would be just P, because I let it be P, and then this would be put equal to 3/16. Yeah, and then we solve for P, right? So I'm canceling 4 and 12 there, get 3, so P would be 9/16, and that is already simplified, so that is the answer there. Okay, so just that. Yeah, because we want both yellows from both bags, and it's 3/16 as given. So I just solve an equation there. I hence complete the tree diagram below by finding the probability on each branch. Okay, so let me just copy the diagram first because I'm not writing on the paper. Okay, so that's fine. I'm just gonna paste it here. Okay, I got it. That's fine, good. Okay. So we know all the probabilities, like the individual probabilities on bag B, because we are given that the red is 5 and the total is 12 again, so 5/12 here. Yellow being 4/12, but simplify it. Well, we don't need to simplify, so I'm just going to do 4 over 12, and the green is 3 over 12, right? And then we already know that for back B, the probability of just yellow would be 9 over 16, yeah? Let me just double check my math there. Yeah, it should be 9 over 16. So if yellow is 9 over 16, red would be 7 over 16, right? Because 9 plus 7 is 16. And all of those will be the same because it's like they're separate bags, so they don't affect each other. Okay. Yeah. Yeah, so it's fine. That's it for part II. Part B. Find the exact probability that at least one of the two beads is selected is yellow. At least one. Well, guys, when you see at least one, it is usually easier if you find the opposite case. So we want P of at least one yellow, yeah? That would be the opposite to P of no yellow, right? Because you want to get at least one yellow. It's either one yellow or two yellows. But the opposite to this is no yellow, right? No yellow at all. But it's not like we're going to find the probability of no yellow, but we want to do 1 minus this probability. It's usually a smarter way. Yeah? Because for no yellow, it is easier to find now. It's just, okay, not that easy actually. It's red, red, and yeah, it's still easy. Red, red, and green, red, right? So it's 1 minus probability of red, red, plus probability of green, red. If you look from the tree diagram here, we don't want any yellow, right? So it's red and red. Can't be red and yellow. We can cancel out yellow here. We're not going to consider it. And then green, red, because we can't do green, yellow. So that's it, yeah? So 1 minus red, red, well, because we got the tree diagram already, so we're going to use it. So red and red, so that would be 5 over 12 times 7 over 16 plus, yeah, plus green and red, so 3 over 12 times 7 over 16, right? Okay, and that would be the exact probability of at least one of the two beads being yellow. Okay, so we do 1 minus. Well, let's use a calculator, yeah? Might be more convenient. Okay, let's see. So 1 minus 5 over 12 times 7 over 16. Because I don't put brackets, I need to do another minus. 3 over 12 times 7 over 16. So that would be 17 over 24. Yeah? I'm just going to put it as that. Okay. Part C. The event X is at least one of the beads selected is yellow. The event X is that at least one of the beads selected is yellow. So it's like from part B. The event W is that a green bead is selected. Well, this is conditional probability, right? So we want to find P of W given X. Well, from Bayes' theorem, if you don't know the name, we do P of W intersect X divided by P of X, yeah? Well, P of W intersect X basically says that given that so we intersect both probabilities. So it has to be at least one yellow and a green bead is selected. So to make this make sense, you must have one green and one yellow, right? Because to satisfy the X, you only need one, at least one. So it could be one. It doesn't have to be two. And because you also have to intersect W here, that means you have to also have a green. So it's just one green and one yellow. So how do we get one green, one yellow? Well, we need to get the green from back A. So it's green and yellow here. Yeah, so just the last branch here. That would be green and yellow. So what is green and yellow? I can look at my tree diagram again. So it's just 3 over 12 times 9 over 16, yeah? And then the denominator will be px, which we already found here because that's just at least one yellow. So we're going to take the answer from the previous part, which is that. Okay, so I'm just going to use a calculator. That is fraction 3 over 12 times 9 over 16. Whoops. 9 over 16. And then down here we have 17 over 24. That is 27 over 136. I'm going to go with that, right? Because I think the first one was fine. Let me just check the part B again, yeah? Can't be too careless with that. So 5 over 12 times 7 over 16. And then minus 3 over 12 times 7 over 16. Yeah, I think that's fine. So we're going to do the next question now, number 2. All right. Okay. Number 2, runners in an athletics club can train with either Coach A or Coach B. For the 400-meter race, Coach A trains 120 for the 400 meters and records the best time x seconds for each runner. The results are summarized by the following statistics. Okay, we have sum of x and sum of x squared. A, calculate the mean of the best times for the runners trained by Coach A. Okay, so 120 runners, right? The mean of the best time. Okay, best time x. So mean x bar is sigma x over n. So that would just simply be 6612 divided by the number of data, which is the number of runners in this case. Yeah, so we're just going to get the answer there from the calculator. 120 runners, right? Yeah, everything's good. So that's just exactly 55.1. Okay, that's part A done. Nice. B, calculate the standard deviation of the best times for runners trained by Coach A. So that's just SD equals sigma x squared over n minus x bar squared. And then square root, don't forget. Yeah, because if not square root, then it's just going to be variance. Yeah. So we have here standard deviation being square root of, just put things in here for method marks maybe. N is still 120, right? Minus, because we already got the x bar, so we're going to use it, 55.1 squared here. Everything is good. We have the right units here. So square root of fraction 36492,902. Is that right? Yep. 120. Minus 55.1 squared. Wow, that's a nice number. 2.2. Okay, so that's the standard deviation. Part B done. Part C, the mean and standard deviation for the best times of 100 runners trained for 400 meters by Coach B are that and that respectively. A 400-meter race consists of equal numbers of fastest runners trained by Coach A and by Coach B. Equal numbers of fastest runners. State, giving a reason, which coach is more likely to have trained the winner. Interesting. Okay. So I'm just going to read the question again here. Because Coach B only trains 100 runners, while Coach A 120. Yeah? And a 400 race consists of equal numbers of fastest runners trained by Coach A and by Coach B. So let's say that is N. Yeah? So let's say I'm going to do table here. So by Coach A, and this is by Coach B. Okay, so it says that the number of fastest runners by Coach A and Coach B are equal in numbers. So let's say X. But the total from Coach A is 120 and Coach B is just 100. So if you find the proportion here of fastest runners, from coach A and coach B, the proportion or probability actually is just n over 120 and n over 100. Of course, because n is the same here for either coach, so you would say that n over 100 is greater than n over 120. So n over 100 greater than n over 120. So yeah, the probability from coach B is more likely. Yeah. So so therefore, which coach is more likely? Yeah, coach B is more likely to have, just going to put here, trained the winner, right? As the reason, yeah, the proportion, I'm just going to use proportion or probability, yeah, of fastest runners the proportion the proportion of fastest runners within the group is greater, and I already wrote here, yeah, okay, as well. I'm just gonna write again, n over 100 greater than n over 120, like that. All right, just some detailed reasoning there. Okay, and that's done for number 2. Okay, I think this one is fine. Number 3, a manufacturer makes components for the car industry. On average, 1.5% of the components made are defective. A, using suitable model, find the probability that in a random sample of 36 components, there are exactly 2 defective components. So this is binomial, yeah, because we have a probability here. Okay, so we're just going to do X modeled as binomial, 36 trials, and 0.015 probability, yeah. So part I, we're gonna do P of X equals 2, exactly 2 there. So that's just gonna be 36C2 probability of success, which is in this case being a defective component, to the power of 2 times probability of failure, which is 1 minus that, to the power of the remaining. I'm just gonna move to the left a little bit, yeah, to the power of 36 minus 2, 34. And of course, I'm just going to do mental math. No, of course not. 36C2 times 0.015 to the power of 2. Whoop, no. See, I need to be aware of what I put in the calculator. You can't be too careless about a calculator. I know you all have that experience where you put things wrong in the calculator, right? Okay, so see if I got everything right there. I think everything is fine, right? Don't you think? So this is 0.08. How many sig figs? Well, I'm just going to go with 3. So 848. Yeah. Okay, 84. You know what? I'm just going to do that first. Just, you know. And then that. Okay, here we go. That's part II. Sorry, part I. Next, part II, more than 3 defective components. So P of X more than 3, that is 1 minus P of X less than equal 3, because we need to include 3 here to subtract from that. Yeah, more than 3. Yeah, okay. So because I don't have a calculator that can do binomial CD, and you guys can because you should have a graphing calculator. So I'm just going to do Desmos. Here's my Desmos. No, that's not Desmos. Desmos calculator. Yep. Okay. So you guys can do it too. I'm just going to do function, and you go to statistical distribution, no, probability distribution, binomial dist here, and the trials were 36, with the probability of success being 0.015, no, 15. Yep. And cumulative, we have to do left, right? and then I'm going to do x less than 3 there, and then I'm going to get the value. So 1 minus 0.997967. Okay, and yeah, so we're just going to use a calculator to do that math. 0.997967. Yeah, and I'm going to round that to 0.00203. I think that's fine. Yep. Okay. And now part B. Once every 6 months, the manufacturer tests whether the proportion of defective components has changed using hypotheses H0 being that, H null, H alternative being that. So this is not equal to, meaning it is a two-tailed hypothesis testing. A random sample of 260 components, wow, is taken and 8 are found to be defective. Okay, using 5% level significance, complete the test. Okay. So yeah, still binomial, right? But hypothesis testing. We don't need to approximate. I think we're still fine with that. It doesn't say approximate at all because 260 is getting large there. So I'm being careful here because it doesn't say, so we shouldn't use it. So we're just going to do again now x modeled as B 260. And because the assumption is still 0.015, right? Okay, so using 5% significance, complete the test. So we're just going to find the p-value, which is the probability of, okay, so 8, right? Let's take a look. 8 should be on the left or right tail. Although it's two-tailed, but you need to find where x is, where 8 is. Is it on the left or on the right? Well, the expected value, right? We can find the mean, yeah? The mean is 260 times 0.015. That is about 3. You just multiply n and p. You get the expected value, which is the mean. Now, because 8 is more than the mean, so we should do the right tail. Otherwise, it's going to be the left. But in this case, we do right. That means we should do greater than. So p of x greater than or equal 8, yeah, is the p-value in this case. And we will compare that to the significance level, yeah. So, well, that would be 1 minus p of x less than equal 7, right? And again, I'm just going to use Desmos again. Let's see, okay. 1 minus. Now I need to change that to 260, yeah? Same probability there. And the left, and then I change that to 7. No, 7. So I get 0.955886 there. Yeah. And then I'm going to use a calculator to do that math. 1 minus 0.955886. So I get 0.0441. Okay. Well, that's the p-value because this is greater than. You got to be careful here. The level of significance should be split into 2 halves on left and right tails. So the actual one we compare is 0.025. So the p-value is greater than 0.025, right? That means we accept now, or we don't reject it, basically. Okay? It has to be smaller in order to reject now, right? So not enough evidence. Yeah. So what does it say here? Whether the proportion has changed. Okay. To support that the proportion of defective components has changed, i.e. it doesn't change based on this hypothesis testing, right? Okay, and that's it, the end of question 3. Statistics on this one is not that bad, right, on this year. Okay. K is studying, number 4, K is studying variables daily total sunshine. Okay, so sunshine is in, I think it's in 8ths of the sky, right? It's I don't remember the name. It's octas, yeah, okay. and daily total rainfall from the large data set for Liming. So Liming is in the south, right? If you guys don't quite get the large data set, I recommend you go check that video. I just summarized everything in 10 minutes and also giving you the patterns from the past papers from 2018 to 2024. K starts with the 5th of May and then selects every 10th day thereafter. A state the name of sampling techniques K used. Okay, so you start from some day and then you're going to go in intervals. So this is not random sample. It's oh, hang on. I might get this wrong because it's been a while. I think it's stratified. No, it's not stratified. It's systematic sample. It's still within the random sample. Hang on. Oh, gosh. Okay, I think I forgot about this. But I'm gonna take my chances here because it's better than nothing. I'm gonna go with. It's not stratified. Stratified is like in groups. So it should be. Or is it random? I'm gonna go with, I don't know if this name exists. Systematic, yeah. Sampling. Okay. Yeah, that's funny, right? Funny name because it's like you go every equal interval. So there you go. Next, K wants to find the regression line of Y on X for these data. B, using your knowledge of large data set, explain how K might need to clean. This is the pattern in that video. You need to know how to clean the data. These data before finding the equation of the regression line. So, the total sunshine would be fine because you only have 0, 1, 2, 3 to 8. They're just 9 numbers. But the total rainfall, some of them do have TR. That is the trace amount. It's a very small number. So we're going to have to change for rainfall. Yeah. We need to change the TR values into numbers, i.e. 0.025 millimeters, because that's like the midpoint. Yeah. And also using might need to clean data before finding the equation of the regression line. And clean data and use midpoints. Yeah. Yeah. Because the rainfall might give you in ranges, right? So we need to do the midpoints now. Oh. No, I don't think so. I think in the spreadsheet it's already midpoint for each day. Yeah. No, midpoints would have been the answer when they have a table for you and they give you ranges. But in the spreadsheet of LDS, I don't think there are ranges there. Yeah. So it's just that. The TR is indeed in need of change. Okay. So that's it. Next, the equation of regression line K finds is that using your knowledge of LDS again. Part I, state the units of gradient of the regression line. Okay, so the regression line, the gradient, right, is delta y over delta x. That's the gradient of a linear equation. The delta y is the rainfall. So it would be millimeter. It's basically asking you the unit here of either one. So you need to know that the rainfall is in millimeters and the total sunshine is in octas. So it's millimeters per octas here, or we're gonna write millimeters per octa, like that. Yeah, that's it. You need to know the units of all the quantities in LDS. Yeah, it is what it is, I guess. Okay. Part II give an interpretation of y-intercept of the regression line. Okay, so y-intercept is basically 0.741. Yeah, we need to give the interpretation of that. So it happens when x equals 0. So when x equals 0, y equals 0.741. That is not the answer. It's just, just some note there. But the way you say, you need to include the context. So we're going to say this is the value of y when x equals 0 so it's the daily total rainfall, in millimeters when there is no sunshine, or when the total sunshine is 0 octaves. Basically that. Okay, this is a good one actually. Good LDS question. Case teacher claimed that the greater the amount of sunshine in a day, the lower the amount of rain there should be. So the greater, the lower, this is negative correlation, right? State giving a reason whether the teacher's claim is true for case data. Well, if you look at case data, you should look at the regression line model. Well, so we're going to answer here from the regression line, as the gradient is 0.199, which is a positive value. This suggests a positive correlation. Positive correlation between amount of sunshine, and the amount of rainfall. Therefore, teacher's claim is not true. All right. Okay, there you go. The teacher used all the data for these variables from the large data set for Leeming in 2015 as a sample. All the data for these variables. All right. So all the data from May 2015 to October 2015. The teacher calculated the product moment correlation coefficient for x and y to be negative. Okay, that's all right. Okay. In a suitable test to determine whether there is an evidence to support the teacher's claim, the p-value was 0.015. That's quite low. That's 1.5%. Okay. Using 5% significant level, state hypotheses and conclusion for this test. Okay, so the teacher, okay, so this is hypothesis testing for product moment correlation. So the teacher found that the, the teacher calculated the product moment correlation coefficient. Suitable test. 5% significant. Okay, so let's open the table, right? So I'm just going to note down. Row is, we need, okay. What's the claim again? To support the teacher's claim. So the teacher's claim is still the same, right? Because he claims before that the greater amount of sunshine, the lower. So he claims that, okay, we're just going to put H now, row equals 0, and H1 row less than 0, sorry, because he claims a negative correlation, and N is, okay, so N is how many? Wait. P-value was 0.015. Is that the p-value? Okay, yeah. I'm just gonna check the table because normally it's not like this, yeah. Okay, so just gonna check the p-value from the table. I mean, I'm just suspecting that the p-value here means the one that we read from the table, right? So usually it should have been the one that we compare against the significance level. Okay, am I? Hang on, where am I? Is it this one? No. Yeah, it's this one. Okay, so we are looking at 0.05 significance level here, yeah, and we don't know n, but so 0.16 is the correlation. So what is this? It's the product moment, the p-value. Interesting. In a suitable test to determine whether there is evidence to support the teacher's claim. I mean, okay, look, because this is, we already have the p-value. It seems like we can use the p-value to compare with the significance level. I'm just going to go with that, yeah? Because I think there's no point using this correlation just yet. So we're just going to go with, because 0.015, this is one tail, right? Because we're testing to be less than 0, so that's one tail. Because 0.015 is less than 0.05, therefore reject H0. Okay, and then we say therefore, yep, teacher's claim. I'm just going to write enough evidence to support the claim, yeah, which is the teacher's claim that it should be a negative correlation. Okay, so part F. For the test in part E, describe the sample. Whoa, okay. So we want to describe the process of sampling here where the teacher used all the data. So this is called census. Yeah. This naming was already in the AS statistics, I remember, in the same year, 2025, right? So this is census because he takes all the data available. Yeah. Or data for these variables from large data set. Yeah, census. Okay. And a possible possible population? Okay. I think I'm going to change my mind here. Okay, because when I read the second one, a possible population, I mean, census is where you take all data from the population. For the test in part E, describe the possible population. Possible population, okay, look, I'm just going to delete the first part first. Possible population now would have been all data for the variables. Okay, so it would have been the daily total sunshine and daily total rainfall from every day in 2025. Yeah, so total, yeah, that's the population. Total daily sunshine and total daily rainfall from every single day in 2015, not 2025, sorry. Yeah, because the large data set only you know, it's only from May to October. So the sample here for the test in part E, suitable tests to determine whether there is evidence to support teacher's claim. The teacher used all the data for these variables from the large data set for leeming. So as a sample, okay, so this is all data from the large data set, but if we say that the large data set itself is a sample from every day in the year, and the year was just selected from May to October. Okay, so we got systematic before, right? This is probably not too random, I wouldn't say. I would say, is it stratified again or quota? I'm going to go with quota, right? So I'm just going to do quota sampling. Honestly, I forgot about these definitions. I hope I annotate the video clearly here. But I mean, this is real exam conditions, so I'm gonna go with that. All right. But the second part should be fine, I think. Okay, so number 4 done. Let's do number 5. Okay, we are good at the time there. Still have mechanics to do. The heights of men in tennis club are normally distributed with the mean of that and the standard deviation of that. A man from the tennis club is selected at random. I find the probability that the man's height is more than 186. Okay, so we're just going to do X modeled as normal distribution 183, standard deviation of 4.9, and then we do variance there. And we want P of X more than 186. It doesn't matter if you write more than or more than equal, same thing, because it's a continuous distribution. So that's just going to be, yeah, you guys can find the probability easily using the graphing calculator again. But I'm just going to, because I have Desmos, right? So I'm just going to use it. You guys can too. So basically, if you guys want to do this in your graphing calculator, so you go to statistical distribution and do normal CD. And here you put in lower tail and upper tail, lower and upper, as so lower should be 186 and upper should be, make it 1,000,000 or something. Mean would be 183 and standard deviation is 4.9. Yeah, so I'm just going to do again normal dist here, 183 as the mean and 4.9 as the standard deviation. So I'm going to do right tail where you guys have different, okay? So I'm going to do greater than equal 186. So if you guys do what I said there about the lower bound and upper bound, you should get the same value. So that's just 0.27087 blah 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 0.270 sig fix. Yeah, I mean if it doesn't say, usually 3 sig fix. Okay, and then part II between that again the same thing. So X less than 185 but greater than 175. So this is inner. Okay, yeah, and then here I have the left part to be 175 and this is 185. Okay, here we go. So that's 0.607. That's it. Okay, hang on. Yep, that's fine. So that's it. Just calculator work there. Just have to be careful, right? Part B. The heights of women in the tennis club are normally distributed with the mean of mu and standard deviation of sigma. Given that 40% of women are shorter than 170 and 15% are taller than 175. All right, so I'm just going to draw the bell curve here roughly. Shorter than 170, right? So the middle is mu, of course. Shorter than 170, you have 40%. So it looks like it should be somewhere here, nearly in the middle, because if you do the area in the middle here, from the left tail to the middle, this is 50. So 40 is here, makes sense, yeah? That means the 170 is here, sitting there. We got to be able to distinguish what side it is in first. And 50% are taller, right? So 15% is somewhere there maybe, yeah? So this is 0.4 probability, and this is the area of 0.15. And that is 175 or taller. Okay, so what we need to do here is get the z values from both sides, make simultaneous equations, and solve. Yeah. I think I'm gonna use the table here because the numbers are nice, so I'm suspecting that we can do the table work. So if you go to percentage points for the normal distribution, which is around this page, yeah, I think they have the value there. Yep, they do. So if you look at the P here, we have the 0.4, 40% in this. So this will correspond to what? So the z value of that would have to be negative because z value to the left of mean would be negative, but because this table is giving you the positive. So what that table gives you is the 40% here of the right tail, and saying that the z value at that boundary is 0.2533. That's what it's saying. But we want the left tail, so we just use symmetrical property of normal distribution. So we got negative 0.2533 instead. Yeah? So you need to understand that if you want to use the table, of course. And for this one, the z value would be what? Well, this is 15%. So, ooh, we don't have 15. Oh, we do. Okay, yeah, good luck. I mean, we're lucky. Okay. This is the one we want. So because this is already the right tail, so it's 1.0364, and we're good. So I'm just gonna close. Let me check the value again if I copied them right. Yeah, I think I did. So I'm just gonna go back to the paper and just make two simultaneous as discussed. So we have 0.253. We are using the z formula, right? So z equals x minus mu over sigma. So x is 170 there because that's the corresponding value, minus mu over sigma. Okay, so I'm just going to make this a single line, equals 170 minus mu. So that equation 1. The other one is, of course, 1.0364. I'm just going to put sigma up already, yeah, because that's the pattern there. And it's 175 minus mu, which is the same mu there. Now, do you see that we can subtract two equations to get mu? Sorry, to get sigma first. So I'm doing 1 minus 2. So it's 0. Let me just put a calculator, not Desmos, here. So it's minus 0.2533 minus 1.0364. So that's going to be minus 1.2897 sigma, right? And then we do 1 minus 2, so the mu's cancel out. We get 170 minus 175, so that's minus 5, right? Yeah. And then we're going to divide this value in my calculator by, no, hang on, it should be minus 5 divided by answer there, because we're going to make a sigma the subject. So there you go, right? So we get 3.87687. So sigma equals 3.88. Let's make that two significant figures, just like, well, we can do one significant, yeah, two significant figures, so 3.9 cm. And we want to solve for mu as well, so mu equals, so I'm just going to use the first equation, so that would be 170 plus, right, 0.2533 sigma. Okay, so I got sigma to be there already. Okay, so I do 170 plus 0.2533 times answer, just to follow that through, yeah. Let me check the math there. That should be fine, right? So 170.982 blah blah blah, so that's equal to that's just 170, right? Interesting. Yeah, quite close to, I'm just going to do 171 here, yeah, because just to keep the same significant figure pattern here from the first part. Okay, so there you go, the two numbers there. The last part, C, a man from the tennis club and a woman from the tennis club are selected at random. Find the probability that both players have heights between 170 centimeters and 175 centimeters. Both players, huh? Okay, so this is compound probability. We select one from either group, which are probably independent, right? So assume, I mean, you don't need to write this, but assume independent. Assume that selection is independent from either group. So we can do probability equals probability of 170, and let's do this, yeah. So I'm just going to do X being men, well, hang on, let's do men as M, normal distribution. We already have men is 183 and then 4.9 squared, and then women would be normal distribution. We already got the value 171 and 3.9 squared, yeah, that's for the women. And then so we want probability of men being in between 170 and 175 times probability of women being in 170 and 175 as well. But we already got, oh, we didn't get the probability of, you know, the men there, so we need to find it first. Okay, yeah, we can find it. So let's use Desmos again, yeah. So I already got the data for men here on the calculator. Let's just change that to 170 here, the left bound, and the upper bound is 185. Sorry, 175. Almost got that wrong. Yeah. So that would be for the men is 0.047283. Just keep it at that. And then let's see, for the woman, do we need to do a calculator because we got 170 and 175 there. So we need to make use of this data, right? So you see, if I draw the simple bell curve for the information that we did use in part B again, this is 170 and this is 175, right? And this is 0.4, this area is 0.15. We don't need to do the bell curve like the formula there. We just do 1 minus that and that to get that area, right? I mean, this would give you a more precise answer. That's what I'm saying, and we should, right? Yeah, so that would just be 1 minus 0.4 minus 0.15. Okay, so what's that going to be? Well, calculator. 0. Hang on, let me look at that one. Wait, hang on, what's that? 0.04747283. Let's check that. Everything's fine. And then times 1 minus 0.4 minus 0.15. Oops, 15. There you go there. So it's 0.021277 blah blah blah, so 0.0213. Here we go. So I'm just going to keep my answer as that. And that is not it yet. We still have the last one here, number 6. I need to hurry up, don't I? The discrete random variable r takes even integer values from 2 to 2n inclusive. The probability distribution of r is given by that, where k is a constant A, show that k of n times n plus 1, sorry, k equals. Interesting. Even integers. Okay, so we know that all the probabilities add up to 1. Aha, so this is series, I think, because you don't know what n is. So you're gonna have like, 1 equals, hang on, let's not put 1 yet. You're gonna have like 2 over k plus 4 over k plus 6 over k plus, and then 2n over k. Hi guys, just a quick one here. This statistics always blows my mind. So as you can see, for the past 28 days as of today, out of all the 7.7 thousand watch hours, more than 90% of those watch hours come from those of you who aren't subscribed to my channel. And that gives me an urge to beg you, please help support me by subscribing the channel. I will return this huge favor by creating more and more videos. I'm going to utilize my teaching experience for 10 plus years to create the videos covering tips and tricks and the hard bits in the topics that most students struggle to understand. It can either be a short video, a long video, but they will sure come up. So that is why you need to subscribe to stay tuned. I hope we have a deal. Let's get back to the walkthrough. Now, because this is weird series, we know something simpler. If you divide the whole thing by 2, you get 1 over k plus 2 over k plus 3 over k plus n over k, right? And then you can, factor 1 over k out, and that will be 1 plus 2 plus 3, all plus to n. And you know that that is the arithmetic sum or series from 1 to n. So that's just n over 2 and n plus 1, isn't it? Yeah, because the common difference is 1, so if you do the formula there, you should get this. Okay? But this is dividing by 2, so that means we need to multiply this by 2 back to get what we want here, which is the sum, and that should be equal to 1. That means this multiplied 2 should be equal to 1. So that is just the equation to solve, right? Okay, and we should get that. Let's hope so. So 2 cancel there. Yeah, we do. Okay, so it's just k equals n times n plus 1 here if you do the simplification there as required, right? Part B. Find the exact value of p from 16 to 26. We got to be careful there. R is discrete here, so probability of 16 less than equal R, that should be changed to less than equal 25. Yeah? Wait, hang on. Variable R takes an even integer. That should be 24. Okay, there you go, because it can't be 25. When n equals 20, so that is 2 up to 40, right? Okay. Okay, so we're gonna find the probability of, so hang on, let me just get k first. So k is 20 times 21, so that is 420, right? Yeah, so that means the probability we want here is just, what is that, 16 over 420 plus 18 over 420 plus until 24 over 420, right? Yeah? I mean, we can do the calculator here. I mean, it doesn't take long, right? We're just going to do like, they're all over 420. So we're just going to do 16 plus 18 plus 20 plus 22 plus 24. No big deal. Okay? So 1 over 420 times brackets 16 plus 18 plus 20 plus 22 plus 24. You just have to be fast there. We got 5 over 21. Seems simple enough. Yeah, I'm going to believe that. Okay, so that's the exact value. Part B done. Part C. When n equals 20, same value, a random value g of r is taken and the quadratic equation in X is formed. Okay, weird. Let's see. Find the exact probability that the equation has no real roots. Okay, so has no real roots. We're just going to go with the flow here. The quadratic equation, if we change that a little bit, is going to become this. Yeah. And the equation in X, right? So X is the variable. That means the G is going to be the constant. Yeah. So we do B squared minus 4AC has no real root, so less than 0. B squared is G squared minus 4, A is 1, C is all that, less than 0. Yeah. So G squared minus, this is a G, not a Y, 12G plus 20, less than 0, right? So we factorize G and G, so 10 and 2, well, very familiar number here. I think I got it in the other paper before. And then that means from the inequality, we can say that G is in between 10 and 2, because that's where the quadratic is below the 0, right? So you get in the range like that. Now, we want G between 2 to 10. So this is basically just from the variable R. It is just basically we want to find P of 2 less than R less than 10, because we want the exact probability, because G is from R. Okay, so that means we're going to do, this is greater than 2, so it has to be 4. Yeah, and less than 10, so it has to be 8. And again, it's just going to be 1 over 420, because it's 1 over k again. Yeah, if you look at this one. So we do 1 over k and then all this, right? And then all the numbers there. Okay, so it's going to be 4 plus 6 plus 8, inclusive there, like that. So I'm just going to do a calculator here. So 4 plus 6 plus 8, like that. So we get 3 over 70. Everything is good. That's the exact value. And the statistics is done. So let's do mechanics, right? Let me change the paper real quick. And here we go, mechanics. Let's do this, right, guys? Hang on. Let me just... Okay, tidy up. Okay, so mechanics 2025. All right. Just going to write here mechanics. The fun part is mechanics, right, guys? Number 1. Some of you said, okay, no way. Okay, number 1. A car moves in a straight line along a horizontal road with a constant acceleration of 2 meters per second squared. The car is moving with a speed of 15 in the direction of acceleration. When it passes a signpost on the road, the car is modeled as a particle. Good. A, use... someone's calling. I need to hang up. Sorry about that. A, use the... Let me just do not disturb mode first. Yeah, guys? Okay. Use the model to find the speed of the car 4 seconds after passing the signpost. Okay. Yeah, well, so V equals U plus AT in it, just so that basically. So V at 4, right? So U is 15 when it passes the signpost, plus acceleration is 2 and T is 4. Basically that. So 23 there, meters per second. Simple. Figure 1 shows the horizontal forces acting on the car. Given that the car has a mass of 800, driving force on the engine has magnitude D. Okay. Resistance 400. Yeah. Acceleration still 2. Use the model to find the value of D. Well, that's simple. That's Newton's second law. So because it's accelerating to the right, that's why we do driving force D minus the resistive force. And there's no friction, right? I mean, yeah, so that's all the forces we have. Yeah, I'm just checking. E equals M is 800. A is again 2. Yeah, so D is just 400 plus 1600, 2000 newtons. That's it. Simple, easy. Number 2. A small box B of mass 2k, G is dragged into a straight line along the rough horizontal plane at a constant speed. A force of magnitude 5 Newton is acting at an angle there. A line of action of the force makes an angle alpha where sine alpha is 3/5. Show that the magnitude, part A, show that the magnitude of normal reaction of the plane on the box is 16.6 Newton. So if we kind of like resolve the force there, okay, so you're going to get 5, this is, because that is alpha, so the vertical would be 5 sine alpha, make sure you understand this. And the pulling force is actually 5 cos alpha, okay? There is a friction, which is mu n, yeah? And there is a weight, which is 2g, okay? And n here, we haven't found it, so in n, I'm just going to put it like that. So 5 sine alpha plus n, this is vertical force, yeah? Because it doesn't move up or down, that means it should be in equilibrium vertically. 5 sine alpha plus n equals 2g. That means n is 2g minus 5 sine alpha. Okay, well, let's just find this force first. Because we have the value of sine alpha to be 3/5, so I'm just going to do the triangle trick here. I have used this many times. I always do this because we don't need to find alpha here. So we don't need to care about the value of the angle. So that means we can put a 4 in here because that's a Pythagoras 3, 4, 5. That means the cos is just 4/5, and if you happen to want to know the tan, it's just 3/4. Yeah. So we got the sign here there. So that's 2g minus 5 times 3/5. So that's 2g minus 3. I'm going to keep it like this first. And now let's do the horizontal force, yeah? So because it is also in equilibrium as it's moving at a constant speed, that means 5 cos alpha would be equal to mu, wait, have we got the mu there? Because this is a rough, show that the magnitude of resultant, oh, I think part A we need to show that n is that, right? So 2 times 9.8 minus 3, yeah, it should be 2 times 9.8 minus 3, yep, 16.6 Newton as required. Okay, so probably next part there, right? At the instant when B is at the point O on the plane, the force of magnitude 5 Newton is removed. Describe the motion of the box after the force of magnitude 5 is removed. So you used to have a pulling force of 5 newtons. So the object, when there is no pulling force, then you would have the upward force here, the normal reaction, to be smaller. So that would become 2g instead, because the weight is also 2g, but you still have friction going on. Because it's still moving, right? Yeah? It's still moving. Because assuming that it has moved a distance before the force is removed. So it's in motion already. But then when you only have friction there, it's going to be decelerated. Because the motion is to the right, but the resistive force is to the left. So it's going to retard the motion. So the motion is decelerated. Motion. Or speed will decrease. Yeah, like that. Okay, that's just one mark there. Find the magnitude of normal reaction of the plane on the box after the force magnitude 5 is removed. Magnitude of normal reaction. That's not hard, so just 2g. So n equals 2g, right? Because you don't have any other force acting up or down. It's just the weight, and the normal reaction should be the same. So that's 2 times 9.8. That's 19.6, right? Yep. Newtons. Okay. And part D here. Given that after the force of magnitude 5 newtons is removed, the box is modeled as particle, air resistance negligible, coefficient of friction as 0.2. I'm just going to write here the speed of the box is 4 meters per second. the box comes to rest at point x, so O to x here, this is 4 meters per second, this is v equals 0, yeah? Okay. And use the model to find the length OX. There you go. So this is distance moved, d. All right. So we have initial speed. Let's use suvat. Distance is d. We want to find, and then initial speed is 4. V is 0. A is something we need to know. T we don't care. We don't know. So I'm just going to use v squared equals u squared plus 2as, but we don't know the acceleration yet. In this case, we need to find deceleration. So the deceleration, right, is from the dynamics of the particle here. Well, sigma f equals ma. Again, as I mentioned, the only force acting on the particle would be the friction. Yeah, and the friction would be 0.2 times, yeah, so it's mu n. Friction equals mu n. So mu is 0.2 and n was 19.6 because the force has been removed, remember. Equals m, which was 2, and there we get a, yeah. So a is just what? 2 cancel 0.2, we get 0.1, 0.1 times 19.6, we get 1.96. There, okay. All right. So there we're going to plug in the suvat, so v squared equals, so I'm going to use 0 squared equals u squared minus, right, because it's a deceleration, 2 times a times s, which is what we want to find. Whoops. And then d would be equal to just 4 squared divided by 2 times 1.96, right? So 4 squared divided by 2 times 1.96. And that is equal to 4 point, is it exact? Okay, just do 3 significant, figure it in. That's it. Okay, that's part D done. E, state one limitation of the model apart from ignoring air resistance. Yeah, again, that could affect your answer to part D. So we can't use air resistance. Well, let's not use particle, but you also could. Well, actually, yeah, we should use particle because look, the refinement of the model, or limitation in this case, can be considered from considering either one of the assumptions, right? So we're just gonna have to look for the keyword assumed or modeled here. It's just particles being modeled as, yeah, the box being modeled as a particle. That's probably the only key pitfall there. I mean, in terms of limitation. Yeah, okay. So what's wrong with that? Because when you assume something as a particle, you don't account for the volume or like the dimensional dynamics, like the dynamics of a rigid body there. So, I mean, for example, the reaction is gonna, you know, there is gonna be some consideration that you need to take when you consider that the reaction is actually not at any single point. Now it can be on a surface, right? Because when you pull the thing, the reaction is just acting on a surface rather than a point, right? Yeah, we're just gonna use that the assumption that the box is a particle. So state one limitation apart from ignoring air resistance that could affect the answer to part D. Yeah, because as this ignores the turning effect, maybe the rotational. Okay, I'm just going to do rotational motion of the box. Like, I mean, when you pull it, right, along the pole, maybe the box will sort of like tilt a little bit, and that might affect the dynamics of it in terms of acceleration and deceleration, yeah? So that's going to be my answer there. Next, question 3. A particle of p mass 0.5 moves with constant acceleration on smooth horizontal plane under the action of a constant horizontal force F. Right. Find F in terms of I and J. Well, F equals ma, of course. And there is only one force, so it's just that F there equals m is 0.5, a is 2i minus 2.4j. That's it, right? Nothing hard here. So it's an I, if you expand that, minus 1.2j meters per second. Oh, this is Newton, sorry. Newton. That's it. Simple. Part A done. Part B. At time t equals 0, p is moving with the velocity of that. Find the velocity of p at time t equals 2 seconds. Okay, so this is v equals u plus at. All in vectors, yeah? U plus a vectors times t. So v at t equals 2. So u is, that is given there, minus 7i plus 7.8j. Just going to put in brackets. And a is just also given at the start, 2i minus 2.4j. And we times here 2, right? So that's going to be minus 7 plus 4 is going to be minus 3i. 7.8 plus 4.8 is going to be 3j. Is that right? 4.8. Yep. Happy with that? Meters per second. Yeah. That's the velocity there. Okay. Right. So that's done for part B. Part C. Find the direction of motion of p at time t equals 2 seconds, giving your answer as bearing in degrees. That's not bad. So here we're just going to draw roughly. This is minus 3 on the left because it's minus 3i and 3j here due north maybe. So it is this velocity vector here from part B. We want to find bearing, so that is going to be, well, if this is north, right? I is taken as due east and j is due north, so that's fine. So this is going to be that angle, the bearing. Okay? So because we already know that it's minus 3 there, so how about we find this angle right here? Yeah? So that angle right there, this angle, is arctan 3/3, right? That physical angle there. Now, we want to add 270 to that. Yeah? I make all positive because this is a physical angle. You should get an acute angle when plugging in the calculator, so that's why I take out all the minus. So I'm just adding here 270, right? Because it asks for the bearing. So we need to add that to 270. So 270 is just this bit here, yeah? Just up to the third quadrant there. Okay. Whoops, sorry. Where am I now? Okay, there you go. Sorry about that. So this is just, so bearing, yeah? It's just, well, happen to know that arctan 1, which is 3/3, is 45 degrees. So 45 plus 270. So you get 315 there, right? Yeah. So that's the bearing. Okay, yeah, I'm done with part C. Part D. At time t equals 0, p passes through the point O, the origin. Okay. Time t equals 5, p passes through point A. Find OA in terms of I and J. Well, yeah, we're just gonna find the displacement, right? So this is displacement, and into that we're just gonna do ut plus half a t squared. So the t is still a scalar, but the s, the u, and the a are vectors. And we want to find the s here, and that will happen to be vector OA, basically. Because we find from time 0 to time 5. So u was still the same, taken as this guy here. So minus 7i plus 7.8j times t, right? So t is going to be 5 here, plus 1/2. A is the same, 2i minus 2.4j, that's the A, and t squared, so 5 squared there. If you simplify all that, you're going to get OA, right? So that is what? Minus 35 for the I, and I'm just going to collect the I here. So this is 25 times, well, let's do 1/2 times that first. I get an I, and then 25 times that, I get 25 here, and then just an I there. And then plus, in brackets, whoops. So 7.8 times 5, so that's 35 plus 4, so 39. And then what do we have here? So 1.2 times 25, that should be 30, but I'm just gonna 1.2 times 25, yeah, 30, so minus 30 there. And then bracket J, right? Is that good? Yeah, should be fine. Okay, so that's minus 10i plus 9j. Okay, meters from the origin in terms of I and j. That's it. Just use SUVAT straight. Number 4, we are good, we are good. At time t seconds where t greater than 0, the position vector of a particle p is r meters, where that A, find the position vector of p, t equals 4. Okay, position vector of p at t equals 4, that's simple. We just plug in t equals 4 in there. So r at t equals 4 would be 4. So 4 square root 4, we get 2. 2 to the 3, we get 8i here, minus 16j, right? T squared. So this 32i minus 16j. That's it, meters. That's it. B, find the exact distance of P from O at t equals 0. Exact distance. Okay, so we got the vector there, the position vector, so we just basically find the modulus or the magnitude of the vector. So a Pythagoras of 32 squared plus 16 squared there. Let me see, so that is 8, 4, and 8, 2, 4, and 2. Well, let's use a calculator actually. 32 squared plus 16 squared. That's 16 root 5, exact distance. So that's exact, okay. And then C, find an expression for the velocity of P at time t seconds, t greater than 0, give me your answer in terms of t, I, and j. Right, so velocity vector is just dr by dt. Okay, so t to the power of 3/2. Wait, hang on, let me check my calculation. Yep, that's fine. It's just pulling the power down, so 4 times 3/2, we get 6, right? 6. Okay, and then t to the power of power minus 1, so we get 1/2. Instead, that's for the I, plus differentiating t squared, we get 2tj. Isn't that done? Yeah, it is. Okay, because they only want that, right? Okay. And then part D, right? At t equals t, the acceleration of p is in the direction that is perpendicular to the line with equation that. Interesting. Normally they would do parallel to either I or j or, you know, some vector. Now this time they do that line. So that line, this is the direction of j, right? This is the, wait, hang on. J is up north like that. I is like this. Isn't it? Yeah, I is like the x, j is like the y, right? Typically. Now, the equation y equals 1/3 x is like that. Yeah. So, well, I mean, we can try and make a vector that is parallel to this line. Like, for example, if I make x as 3, y would be 1, right? Yeah? I mean, you can do any vector because it's only going to be parallel to this vector. So let me just show you. So let's take that the vector that represents this line is 3i plus j to that gradient, yeah? The same gradient as the line, 3i plus j, because the gradient is run by 3 rise by 1, so that's 1/3. Make sense? Now because it's parallel, right? It's parallel to this vector here. So that means we need to find some multiple k where the acceleration of p is going to be, so the acceleration of p is going to be put equal to a multiple of this vector because it's parallel. Wait, it's perpendicular. Sorry. No, okay. Yeah, I read the question again. Okay, let's do that again. This is the equation, y equals 1/3 x. So we want the equation that is, perpendicular to this. So it's just, let me just make it at the origin for simplicity, yeah? So that's going to be this equation, right? It's going to be y equals minus 3x because you need to multiply the gradient to -1 or you flip the fraction and put a minus sign. Okay, so let's take 1 point on that. So if, taking 1 point, the same approach here. So if we have, say, x to be -1, let's say -1 is here, y will be 3 in it, yeah? So like that. So we're going to take this vector, -1, 3, again, using the same approach there, -1i plus 3j. And that is the acceleration there we need to put equal to that vector, perpendicular to y equals 1/3 x. Now, but we don't know about the acceleration yet. We need to differentiate the v vector there. So let's differentiate around here first. So a of particle p is dv by dt. Yeah, differentiate this guy again, right? So a half times 6 is 3, and then this -1, so we get that. That's I plus t 2j, yeah? Because differentiating 2t gives 2. Okay? And then we're going to put that equal to this. And we want to find the value of t. So a at t is going to be 3t to the... So that's basically square root t, right? Wait, no. 3 over square root t, I plus 2j. So here we're going to do then 3 over root t I plus 2j equals k minus I plus 3j. Now we do vector method where we equate the two components separately. So root 3 over root t would have to be equal to the I component on the other side, which is minus k if you expand that out. Yeah? And 2 would have to be put equal to 3k. Yeah, on the other one. So that means k is 2 over 3. And if we plug k back in here, we're going to get t. So root t equals minus 3 over k. Wait, that's impossible. Interesting. How is that going to be perpendicular to that? I mean, root t can't really be a negative value, can it? Oh, I see. Hang on. Right. Okay. Wait. I forgot to consider the fact that this can also be 1 and minus 3 down here. Right? It can also be this vector. Right? It can be either way, right? Because it's just perpendicular to that line. So let's change that to 1 minus 3, right? Rather than minus 1, 3. So 1 minus 3. So I'm just going to change this to this. See if it works, yeah? Okay. No, still the same problem. Yeah, not going to work there. Yeah, k is still a negative. That doesn't make sense. What am I missing? Okay, I still have time. I'm going to take some time to double check here. See if I miss anything. Oh, wait. Yes, I saw it now. I differentiated incorrectly from part C. This should have been a minus. Yeah. All right. Yeah, okay. That's good now, I think. Okay. This should have been minus as well. This should have been minus. Yeah. Okay, so that's still fine. We're just going to take that one. Okay, we're not going to change it now. But this one should be a minus. And this one is a plus, right? So we get a minus 2 over 3 there. Wait, hang on. Wait, what? I'm confused now. Oh no, this one is a minus. Yep. Okay, yeah. So let's do this one again. That one is already right. So this is minus 2 equals minus 3k. Okay, so k is a positive now. Makes sense. All right. Yep. You see, I didn't force it to be positive somehow because it didn't make sense. So that's why I stopped and checked. Yeah. So root t is now 3 over k, which is now 3 over 2 over 3, which is now 9 over 2. Right? Just checking again. See if there's anything wrong. Yeah, it's just a fraction. So t is just 9 over 2 squared, which is 49 over 4. Let's keep it at that. Yeah, 94 over 4. That's it. That's the value of t. That should be fine. Okay. Number 5, probably the last one, I hope. Isn't it? Oh my god, there's 6 questions. All right. Cool. We're cool. I think we're cool. Okay, number 5. Projectile. Small stone is projected with a speed 14 from point A, from point O. I'm just going to sharpen my Apple Pencil first. Yeah. 14 from point O on the top of the cliff. The point O is h meters vertically above point N. Okay, here. Point N is horizontal on the ground. All right. The stone is projected at an angle theta above the ground, above the horizontal, where tan theta is 1 over 2. Again, we're going to use that triangle trick. The stone strikes the horizontal ground at the point A, where NA is 40 meters. All right, everything is included in the diagram. The stone is modeled as a particle moving freely under gravity. Using this model, find the value of H. So that's just the displacement vertically. All right, so do that, guys, in 2 directions. So, okay, so we're just going to do negative H, yeah, because it's negative there, but H is probably a positive values, equals, because I'm going to convert upwards as being positive, so UT, I'm using S equals UT plus half AT squared, yeah? So U is 14 sine theta times T, we don't know, plus half, and then A is minus 9.8 T squared, yeah? And then we should have done the horizontal first. 40 equals U, which is the speed on the horizontal, cos theta times T. Yeah, so the horizontal information will give us the T because we already know theta here. Again, the triangle trick. So tan is just opposite over adjacent, 1 over 2. So that makes the hypotenuse square root 2 squared plus 1 squared, which is 5, right? So that means the cos theta would just be 2 over root 5. So T is 40 over 14 times 2 over root 5 here. Yeah? So that would be, I'm just going to simplify here. So that's 10 over, simplify 10 root 5 divided by 7. Yeah? That's it. Right? So it's 40 over 28. Cancelling by 4 is 10 over 7. Then root 5 will go up there. Okay. And then we're going to use the T there to find the H here. So H will be equal to taking all the negative sign there, 14 times sine is 1 over root 5, t is 10 root 5 over 7. There is a reason why I don't do decimal here, because sometimes you can get cancellation here like I'm getting now. Yeah. Wait, where was I? Yeah, that's fine. 1/2. Ooh, this should also be a negative, right? Almost forgot. And t squared is just that. We're gonna put it in a calculator anyway, so minus 14 times 1 over root 5 times 10 root 5 divided by 7. Is that right? Yep. Minus 1/2 times minus 9.8 times 10 root 5 divided by 7 squared. Oh, see? Nice number. 30 meters. There you go. Wait, let me check if I put everything in correctly. 1 over root 5. Yep, minus there. Yep, that should be fine. 30, happy with that. And B, the maximum height of the stone above the horizontal ground. Well, it's just around here, right? So we're going to have to do SUVAT again. V equals 0. And that's part A. Part B, so V equals 0. U is 14 sine theta. And A is the same, yeah. So let's do V squared equals U squared plus 2AS. So V is 0. U is 14 sine theta, 1 over root 5 times 10. Wait, that's it. 14 sine theta is just that. Yeah, 14 sine theta squared plus 2 times A is not 9.8 minus, and S is just the distance from point O vertically up to the maximum point only. But we want to find the maximum height, so we need to add that with the H that we got earlier, right? So you got to be careful there. So S is just 14 squared times 1 over 5 there, just square of that, divided by, right, because we moved that and then we divide both sides, so we get 2 times 9.8 here. So 14 squared divided by 5 there, up there, and 2 times 9.8. Oh, nice, 2. Everything is correct, okay. So that means the maximum height, yeah, would be 2 plus the H, which is 32 here, as the answer. All right, we need to add the H above the horizontal ground. The horizontal ground is at N, yeah. Okay, that's done, good, easy. And the last one here, number 6. Okay, uniform rod AB has a mass M and the length 2A. Okay, particle of mass 2M is attached at the rod there where AC is 0.5. Okay, the rod rests with NA on a rough horizontal ground, and this is against B, a vertical wall. The rod lies on the vertical plane. The rod is in equilibrium angle alpha to the wall. Vertical wall is modeled as smooth. Magnitude of normal reaction on grounds R on the ground. The magnitude of force exerted on the rod by wall is S. So let's draw that quickly, yeah. So we have a rough ground. Usually, if you want to indicate that there is a friction, we usually do that. And when it's smooth, we don't do that dashed lines, yeah. And we are told that the reaction at the ground is R. The reaction at the wall is S. Okay. Find R in terms of A and G. So normal reaction, yeah, it should be perpendicular. Okay, so let's complete the diagram here that I have. So we have a particle here, 2M. So that's 2 big M and then G. And then the distance here is just, hang on, is 0.5A, right? And the rod is uniform, so there is a weight, I guess, and the weight is M, and because the rod is 2A, so that should be about the weight, which is what? you know, of course, 1A from that end. And do we have anything else? Yeah, I think that's it. Okay, so find R in terms of M and G, 1 mark. Right. Obviously, we can do vertical force because R is most relevant to vertical force, and the feeling that I have here is because it's 1 mark, so it should be straightforward. You take the most relevant formula or equation or whatever you call it to find R quickly. So R equals 2mg plus mg, right? That's just vertical equilibrium there. So it's 3mg. That's it for A. For B, show that S is mg tan alpha. Now S is the reaction acting to the left. Now how about we take, so look, you can only consider 3 things separately. Moment, vertical force, horizontal force. If you have used vertical force on A, then probably something else on B. So how about moments? Because it's simple. You just take moment about point A. So the point A is down here, yeah? This is point B. So moment about A, let's see. I can ignore the force R completely because there's also friction, don't forget. And friction is probably acting to the left there. That's friction, okay? So because we don't know what friction is, we should take the moment at that point. Okay, so moment clockwise, right? So I'm going to do 2mg clockwise. Yeah, about this point. Well, we know the angle, right? Oh, we know the angle here, alpha. So that means, let's do theta here, yeah? So, I mean, if, let's say we know theta, actually we do, but it's given us alpha, but I'm just going to do theta here. So if we have theta here, it's going to be 2mg. The distance here is going to be 0.5a cos theta. Yeah? Like that. I'm just going to put everything in first. Yeah? And then plus, similarly, mg, again, because this distance is a, so I have the same way, a cos theta. All right, that's the clockwise moment, total clockwise moment, and the anti-clockwise moment is going to be from the force S. So S times this distance, and this distance is just going to be the length of the plank or the rod times sine alpha. Is it? Wait, no, cos alpha. So we're going to resolve that distance to this distance. Okay, so it's cos. So S times the whole length is 2a cos alpha. Yeah? Then we can find S. Now look, cos theta is just sine alpha, right? Because theta and alpha add up to 90, so you can just do that. When A and B add up to 90, so cos A equals sine B. But we are given what? Are we given anything? No, we're not given the angle yet. Actually, we don't care about the angle because we're going to keep the alpha anyway. Yeah. So we're going to change it to, okay, I can cancel the A out, right? So I'm just going to cancel the A out here. And then I have here 2 multiply 0.5, I get 1. So that's mg. Cos theta is just sine alpha as discussed. And mg sine alpha as well here equals 2s cos alpha. So I'm getting 2mg sine alpha here equals 2s cos alpha. Yeah, that should be it. S, 2 cancel, we get s mg tan alpha because you divide by cos alpha on both sides. You should get that. Okay, so that's it. Yeah. Part C. In the refined model, okay, we have a lot more down here. The vertical wall is modeled as being rough. Right. The magnitude of normal reaction on the ground is R1. Oh, okay. State which is greater, R or R1. All right, so we're just going to use this diagram here. Now, because there is a friction now, so R1 is just the same R, but it's just for the case where there is a friction on the wall. So friction on the wall would likely act depending on because when imagine if there is not enough friction to hold this rod intact in position like that, it's gonna tilt down like that, right? So it's gonna go like that. That means this end will be moving down, so the friction should hold against that tendency of motion. So friction is upwards, this extra friction, friction at B. That means there is now a greater upward force with the R. So if we consider this second case, so R1 with the friction upwards would have to now be equal to 2mg plus mg. So the downward forces are the same. That means R1 is now 3mg, but has the minus friction here. Versus before, you only have 3mg with no subtraction. Now you have some subtraction. That means R1 is smaller than R, right? Do we have to, reason? Because the friction at the wall is upwards, right? So to balance that, the R1 needs the reaction. We say in general terms here, the reaction at B, it was at A, right? The left, the bottom left reaction there needs to be smaller. That's it. Because now there is an upward force here that will subtract from 3mg. And that's C done. Now part D, some like a new diagram probably. Okay. A second particle of mass 3m is now attached to the rod at B. Okay, so just that extra one. The rod again rests with an A rough horizontal ground and in B against vertical wall. The rod lies in the vertical plane, Now limiting equilibrium. Okay, the vertical wall is again modeled as being smooth. Alright, no friction. The coefficient of friction between the rod and the ground is mu, given that tan beta is 1/2. Show that mu is 1/3. Okay. Right, this is 6 marks. So it's like doing a new question, guys. We probably have to take it as that, But I think we can make use of some formula we got earlier, right? Because this is still 0.5a, right? It's just the same thing, but we have an extra, like extra weight here, 3mg, with the mg here and 2mg here, right? Second particle. Everything else is the same. Now this is beta. Okay. So we're just gonna find the reaction here, R again. So R is 2mg plus mg plus 3mg. Now it's gonna become 6mg, right? No, not the answer yet. Okay. And what did we find earlier? We found S, right? So S would be, we're gonna have to take moment on the same point there, but okay, so this is vertical force, done. Let's do moment at A again. So it's gonna be, it's just the same thing here, guys. There is just an extra clockwise moment on the left side, Okay, so, and the rod and everything is still the same length. So 2mg 0.5a, that would be sine beta instead, right? Because before we got sine alpha, right? So now because the angle changes to beta, so we're gonna do sine beta instead, and then plus mg times a sine beta, that's for the weight, and then plus 3mg times a 2a sine beta as well, and this will be put equal to the anti-clockwise moment S here, S, times 2a cos beta instead, right? So we're going to get S there. Now, we can simplify everything there. So this is, so I'm just going to do mg sine beta here. And how many of them do we have? So 2 times 0.5 is 1. This is also a 1. This is a 6, right? So 1 plus 1 plus 6, that's 8. So it's going to be 8 here. Divided by what we have on 2a here. So 2 cos beta, because a would cancel to begin with. So that's going to be 4 mg tan beta, right? Okay, now that's the S there. And then lastly, we consider the horizontal equilibrium, because this is again limiting equilibrium. That means F equals mu and R, yeah, you would have to be equal to the S, because S is the only force acting against friction there to balance it. So we put it equal to S. That means mu equals S over R, so 4 mg tan beta divided by R, which was 6 mg, this guy right here. All right, so that would be mg cancel. Well, tan beta is 1 over 2, so 4 over 6 times 1 over 2. And that is, of course, 1 over 3 as required. And that is done. I'm at 12 minutes early. Okay. Probably not going to check, right? I'm just going to take my chances. Probably more worrying on the statistic parts. Okay. I'm going to stop the timer and mark the paper, guys. See you in a bit. Alright guys, I'm back and I have marked the paper. I got 96 out of 100, so I got 4 marks wrong there. Let's see what I got wrong. So let's do statistics first. I gotta admit that it's embarrassing for some of the wrong questions, the wrong answers there. Alright, this one, yeah, this is not embarrassing. This is misunderstanding, okay? So in this question, this is 2C. Yeah, they give you that the other coach also has the mean of 55.1, which is the same as from coach A, but the standard deviation is different. So standard deviation in the group A was 2.2. So coach B, the runners, yeah, have larger standard deviation. So I got the answer right. Coach B is more likely to have faster runners, like the winner there, to have trained the winner. But the reasoning is wrong. So this is not what is meant to be. Although, I mean, I consult with the AI and it says that the reasoning is mathematically sound, but it's missing the picture here because the the question specifically says that the mean is 55.1 and the standard deviation is 3.6. We need to refer to those data there. Now how? Well, think about it. So if we talk about coach A, right, with a smaller standard deviation. So smaller standard deviation means that, so that's coach A. And coach B, I'm just going to use maybe a different color here for coach B. So let's use orange there. So if I do legend coach B here. So coach A has a smaller standard deviation. So if you like the bell curve, it's kind of like more clustered towards the mean compared to coach B where it's like this. So it's less clustered to the mean. So the mean is still the same as 55.1, but the data is more spread out. It's more spread out to either side. That means if we only take the proportion where, you run fast, yeah, or actually the time taken, right? This is talking about the time taken, right? So run faster is probably this. So as you can see, the likelihood of, let's say, the probability, or in this case, the area of runners with smaller time, i.e. faster, would be more. If you can see the area of the left tail there, the lower tail, right? It would be more proportion. It's talking about the same thing but different aspects. I talked about also the area, the probability, is more, but I just used you know, like the crude proportion because they have the same fastest runners. I mean, I was fixated to that keyword fastest runner being the same, so I did probability just like that. But I think, yeah, the more proper way should mention the mean and standard deviation. So equal mean, different standard deviations mean that one is more spread than the other. And the more spread one will have the faster runners, we have more probability for faster runners, yeah, or even slower runners, like the extreme ends of the bell curve will have more areas compared to the coach A1. All right, so those are just the reasons there. Okay, so I just know that there need to mention the statistics given, and I already did explain that. All right, so that's wrong, so I deducted 1 mark there. And question 3 is fine. Number 4, yeah, that was embarrassing. Octas are the units for cloud cover. I was mistaken that I took it, so this is sunshine, so the units is just hours, yeah, so this should have been hours, yeah, that should be hours there, not octas. So it's just millimeters per hour would have been the right unit, so I minus 1 there. But this one is a follow-through, I think, so I got the context right. It's just the number, the daily mean rainfall when the total sunshine is 0. And I don't think that they're gonna take mark away if I write 0 octas there, so it is still fine. So for part F, let me just, yeah. For part F, yeah, I overthought too much about the type of sampling. Wait, where's this again? This is question 4 in it. Yeah. So describe the sample. We just describe what data are taken to be the sample. Well, for the second part here, I got it right, because it would just be every single day in the year 2015 for Leeming. But then for the first one, oh, and by the way, I got this one right. It's systematic sampling, believe it or not. Yeah, that was just a guess. Yeah, I remember the name vaguely, and I'll just go explain this one. So the total, sorry, the part I here, the sample. For the sample in, so this test, right? The sample is basically, the data for this sample is basically from the large data set. And the large data set, yeah, the sample is basically just the days from May 2015 to October 2015. I should have said that, right? This is the type of sampling, not the sample itself. We need to describe the sample. I just missed that. But then this one, I got it right. Yeah, it's just every single day in the year 2015 for Leeming. So what should have been said here instead would be the data in large data set for the data in large data set of daily mean, what was it? Daily mean, daily total sunshine. I'm just going to do DTS there, and daily total rainfall for Leeming, yeah, for Leeming in 2015 from October to, sorry, from May, yeah, this is from May to October, right? That's it. That would be the sample for this one, right? And I didn't just write that, so I got minus 1. What's embarrassing is the octa here, guys. I was mistaken that with the total, the cloud cover. Cloud cover is octa, yeah, basically. Anyway, but that didn't hurt much. Other ones are still fine. Okay, and number 5 here is fine. Okay, so next, the mechanic. There is only one mistake in mechanic. It's just the last part here, I think. No, not the last part. Number 4. There's no need to mention the question here. This is a super silly mistake. This should have been 81/4. And I got 49 somehow. I thought that was 7 squared. All right? Maybe it was in a little bit of a rush. And that's it. Every other question is fine. Yeah. Okay. Now let's do overview. Yeah. Yeah. All right. So, well, in my opinion, this paper isn't that bad. I think the 2024 is harder. If you haven't seen the 2024 walkthrough, just go check. Yeah. I think this paper is slightly easier. All right. Or maybe somewhat easier, not slightly. But yeah, overall it's fine. Yeah, this one I almost got it wrong though. Like part A, I thought it was just a single probability from the second back, but I mean the 3/16 here. But that wouldn't make sense, so I changed my mind to, you know, the compound probability from both backs, and we got to do the tree diagram here. Yeah, this one, if you know how to do it faster, then otherwise you would have to do red, yellow, 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 and green, yellow. I mean, which is not that bad considering you don't have many yellows here, but imagine if there are 3 backs now. Imagine if there are 3 backs, then it would have been a nightmare, yeah, to do all the yellow cases, because you can get only 1 yellow, 2 yellows, or 3 yellows, and the 2 and the 3 yellows can swap around. So you can get red, yellow, red, or red, red, yellow, and it's going to be horrible there, all right? It's easier to do 1 minus probability of no yellow at all, right? And here part C is conditional probability, so that should be fine, right? Number 2, yeah, A and B should be fine, right? But part C, yeah, okay, part C, the learning is when they give you the statistics to mention, then you should mention. And again, we consider the spreadness, yeah. So the more spread the data, the more likely that the extreme ends of the data will have higher probability, if that makes sense, right? As I already do the bell curves here to compare. So the orange bell curve will have more areas towards either end, yeah? All right. So that's fine. Number 3. Number 3, yeah, everything is fine here. So this case, I mean, in my opinion, you don't have to use approximation here, although the probability is small and the sample is large. But I mean, if there's any appropriate probabilities approximation, that would have been Poisson approximation, but it's not in the syllabus. It's not in the UK spec. It is in the international spec, but it's not in the UK, so that's why I didn't go for it. At least it also, plus it doesn't tell you to do that, so that's why I didn't do it. Usually approximation is required when the question says so. If it doesn't say, you don't need to, okay? And again, we can use the calculator, right? So I mean, would have been needed, approximation would have been needed in the international spec paper, yeah, because they don't have the table there to do the 0.015, and calculator work isn't allowed. Although you could use calculator to check, but it's not allowed, like to quote the value from the calculator. And yeah, so that's not significant, so we accept H0, that's fine. Well, number 4 is a tricky one, I think, apart from me getting the unit wrong there, but it's large data set here, so you need to be aware of all the units. You check the video, right? Check the video, the large data set. I very carefully studied the large data set and made that video. It's just 10 minutes. I suggest you guys go watch, right? And I guarantee that you will get something out of it. Just 10 minutes, yeah. And I think, yeah, I mean, it's only 10 minutes because it shouldn't be worth much time to watch, because the marks you got from it is not a lot. But in this question, Well, for B, right, there's 1 mark there. And for F, there's 2 marks there. So it's probably about 3 marks regarding the things you need to know from the large data set, right? Part A, like part 4A here, this is not like usual because I've never quite seen it ask like the type of sample here. Yeah, but yeah, you have random sampling, stratified sampling, quota sampling, and systematic sampling. So systematic is the one where you sort of like go in intervals to take the sample there. Random sample is just random, like you don't care about anything, you just take random. You use some random number generator. So let's say you want 100 sample size of 100. So from say 1,000, so you would ID from 1 to 1,000, and then you just go random generator. So you would generate 100 random numbers, and then those numbers will correspond to the IDs of the sample. Yeah, and you just go select them and so on. But this is like systematic, so you go 1, 101, 201, and so on, maybe, for example. So that's systematic, yeah. So yeah, the cleaning, right? So TR values, basically in the spreadsheet, TR values is trace amount. So it's a very small amount, but I just suggest a 0.025 here because the midpoint of the TR value here is 0, so it's a range of 0 to 0.05. So anything less than 0.05 will be put as TR value. That's why I did 0 plus 0.05 divided by 2. And that's the midpoint there. I mean, if you answer 0, then would have been fine as well. But this is more accurate one. Okay, and I did mention that in the video, in the large data set video. You should go watch. Yeah. And then yeah, part C, the units. Okay. Interpretation. Yeah, that was right. So this one is basically just referring to a bit of large data set context. But yeah. Okay. So part E, I almost got it wrong. Yeah, it's just using the p-value straight. There's nothing to do with this thing. So this is a redundant piece of information here, minus 0.160, I think. Yeah, we can just use the p-value there, right? And yeah, this one, describe the sample. I already mentioned that in the correction. So the sample is just all the data in the large data set, because the large data set is just from May to October. So that's not the population. The actual population would be every single day in the year 2015 for Liming, yeah, on 2 types of numbers there, which is the daily total sunshine and the daily total rainfall. Okay, that's fine. Number 5, yeah, it's just normal distribution for both of this. Nothing particularly hard here. I think it was fine. Just make sure you understand how to calculate from the given probability or area here to the mu and sigma. So when they ask you 2 things, usually it's just simultaneous. Just get that intuition, yeah? All right, so you need to find 2 equations to solve simultaneously. This one is just find the probability of 2 of them and assume that they are independent, so you multiply them directly. So this is still fine, yeah? Number 5. Number 6, yeah, number 6 could be a little tricky here. Well, at least you need to know first that the probabilities add up to 1 in the distribution, right? So that's fine, but this is okay, it's subtle, I think, but you just need to know that 2, 4, 6, I mean, if you have done enough competition math questions, maybe, you will see that you can manipulate the algebra of the series there, and it's just basically an arithmetic series where you can find the sum easily there. It's not that obvious, I would say. So yeah, be alert for this kind of question. You don't need to be fixated to just the scope. I'm just saying that you should be open to these kind of tricks that they play with the math here, and they expect you to know that. This is incorporating pure math knowledge, right? And part B is just finding the probability within that range. So be careful about the signs there, because this is including 16, but not including 26. So that's why I put that to 24. And again, we can use the K value we got earlier. And for part C, right? Yeah, this is obviously incorporating pure math, right? So you need to do this discriminant first, and then find the range of G, and then I got that to be 3/70, which was fine. And mechanics, right? So let's do mechanics. Yeah. So mechanics. Question 1 is straightforward. That's probably easy, so I'm not gonna go into details here. Number 2, let's see. Number 2, I think is still fine, right? Just force equilibrium again. Yeah, reaction is fine, just resolving the force. Describe the motion. Yeah, this can be tricky. If you don't do physics, then this might not be obvious, right? When you have a motion of something moving, and then you put it in the state where there is a force retarding the motion. In this case, it's friction, because we didn't remove friction. Friction is always there. You can't remove friction. As long as the object is moving, there is always friction there, if the plane is rough, and it is. So when you have friction, you have deceleration. So eventually, this object will stop if there's no other force acting on it. Yeah. Yeah, so that's part B, right? Part C, this is fine, just asking about the reaction. Part D now, it's incorporating SUVAT, right? So we did SUVAT there. So usually sigma F equals ma and SUVAT are linked by the acceleration, meaning that you would need the acceleration from the dynamics, the F equals ma, to calculate something in SUVAT, or vice versa, right? This is the former case where you need the acceleration to calculate the distance traveled, all right, or displacement. And yeah, this is okay, like the limitation, because you assume that the box is a particle, so we ignore the rotation, and that might affect the motion of the box, right? Yeah, so that's right. This one, yeah, nothing particularly hard here. You just need to know. I think you would be okay with A, B, and C, right? Oh yeah, C might be a little trickier. You just have to get the bearing right. So you get the velocity first. Whenever it asks about the direction of motion, you refer to the velocity vector. Okay? There is a rare case where you refer to acceleration instead. That is when you don't have any initial velocity, and you start from rest, and then you exert the object by a force. So after you found the acceleration, you use acceleration as the direction of motion when it starts moving. Okay? But in this case, we have a velocity, so we use it at t equals 2. And the way you find bearing is to do j as up north and I as due east. And then you sweep from the north to the vector here, the vector like this vector here. Yeah, so this will be the bearing there, okay, which is 315. The interesting bit here, I think, is part D, because if you don't know that you can use this other SUVAT equation in the vector, then you probably don't know how to do this. And that is the case. You can use this as a vector equation, so that's to put S as a vector, U as a vector, and A as a vector, and T is a scalar. And then you can just solve this. Yeah, get the S as the displacement vector OA. Okay. All right, so that's just something to stress there. Question 4, yeah, this is similar to, I think to, was it AS paper where you have to differentiate R? Yeah, maybe. Yeah, it's very similar here. You find the position vector of P at t equals 4, that's just substitution straight, that's fine. Exact distance, that's just to find the magnitude of the position vector. C expression for velocity, that's just derivative, so you differentiate. And part D here is probably harder. So let's talk about part D again. I almost got it wrong in the sense that you need to do the perpendicular and not the parallel one. So this one is a line, but the acceleration must be perpendicular to this. So it should be this. So I just made up some vector here, guys. I mean, it can be something else. You might prefer like 2i and 6j here. It would have done. It would have done. Yeah, it would have done. That would do. But I just made it simple, right? So I made it 1 minus 3. Could it be minus 1 and 3 still? Yeah, it could. It doesn't matter really. It's just, you know, if you multiply this by minus, then you would have got the same thing, and you would end up with the same k value here. And I mean, at least the t value, you would have the same value there. It doesn't really matter. I mean, k might change, but the t will not, right? And then, yeah, the key thing here is to use vector method, because when a is in the direction of that vector, it means that a is put to equal to k times that vector. That's the key part that I need to stress here. And you solve simultaneously, you get t, and I made a stupid mistake there. Yeah, 9 squared is 49. That's wrong. It should be 81. Yeah, and that should be it for that one. Number 5. Yeah, projectile. Just do suvat for both axes and then link them by time, right? Because there is only one thing that is the same in both direction, time. That's why I found time first from the horizontal and use it in the vertical motion to get the h here. And then we use it again in part B because we want to find the maximum height. So the key is to put, so you start from O and go to the maximum, where velocity in the vertical direction is 0, right? So that's just it. Number 6, yeah, maybe more difficult than number 5 here, static of a particle. Again, usually, oh, this is static of, no, not a particle, static of a rigid body. So there are 3 things. In AS, there would have been just 2, sigma fx and sigma fy, but in A level, there are 3 things: moments, sigma fx, sigma fy. They're all resultant as 0, right? The resultant of either one of those is 0. And you just consider which one to use first. Sometimes you need to do moments first, but in this question, I needed to do vertical force first to prove that, to find R in terms of M and G. Because R is directly involved in vertical equilibrium, right? R is like vertical reaction at point A. So I did that. And then once you use that, you're not going to use it again. Yeah, a good hint is you're not going to use the vertical force to resolve anything on this part again. Maybe moments, that's what I do in B. Yeah, moments. So to find the force S there, because we don't know the friction yet. So we better get rid of friction somehow. Mathematically, you take that as the pivot, or the point you find the moments about in B here. In C, yeah, now we use horizontal force just to do the friction there. So yeah, oh no, in C it asks about whether R1 is greater or smaller than R. So yeah, I explained that because if the wall is rough, then you would have extra friction there on the vertical equilibrium, and that makes R1 smaller. Alright, so if you don't understand that, just go wind back and check this part in the walkthrough. Yeah, part D is like another new diagram there, but kind of similar locations there, except the particle is at point B as well. So that would cause extra clockwise moment, and everything is kind of like similar here. And then I solve for mu. So this one at the last part of the work here, it's horizontal force equilibrium, right? So that is just putting sigma F, the friction here, which is to the right on the ground here, equal to the reaction here. Yeah, and just that, because we only have these two to be the horizontal forces. And then we found mu to be 1/3, and that was right. And that was all it, guys. If you have watched this far, I think you find it useful, and please help support me, or like the video at least. And don't forget to check other videos. I'm sure that you're gonna find them helpful, right? And I'll see you in the next video. Bye.